Buonasera, buonasera e benvenuti. Accomodatevi pure. Allora, tra le tante invenzioni che hanno cambiato la nostra vita, probabilmente diciamo, le due principali, o due almeno che hanno cambiato forse in maniera determinante la mia di vita, sicuramente internet e dall'altra lo smartphone. La nostra identità, oggi come oggi, non si gioca più soltanto sul piano fisico. La nostra identità è costituita da dati, da una parte digitale, da una parte fisica, che si integrano creando la realtà che viviamo oggi. Quindi diventa sempre più importante andare a capire cosa vuol dire preservare questi dati, chi controlla questi dati, come vengono utilizzati questi dati e anche come noi ci comportiamo, quali decisioni prendiamo nel momento in cui siamo in rete o utilizziamo i nostri device. Nel 2016, secondo gli ultimi rapporti, il rapporto del Clusit, l'Italia si è classificata quarta al mondo per il numero di attacchi informatici. Una cosa che se volessimo quantificarla in termini monetari, si può quantificare un danno di oltre 10 miliardi per le aziende e per le imprese. Quindi il tema della sicurezza informatica, dell'utilizzo dei dati che tutti noi produciamo, diventa centrale, diventa un fatto non soltanto più legato all'imprenditoria o alla tecnologia, ma diventa un elemento culturale, delle competenze che ognuno di noi deve acquisire e cercare di maneggiare con consapevolezza. Siamo molto contenti di avere qui oggi uno dei più autorevoli esperti nel campo della sicurezza informatica e della privacy. Dopo tanti tentativi siamo finalmente riusciti ad averlo qui. Quindi lascio la parola a lui, a Mikko Hyppönen.
Thank you. So, my name is Mikko, and I'm from Finland. And 10 years ago, every one of you had a Finnish phone in your pocket. And today, none of you has a Finnish phone in your pocket. Am I right? Pretty much right. 10 years. 10 years is nothing. Time travels really fast. And time travels especially fast on the internet. When I started working with computer security, the year was 1991. I was hired for the same company where I'm working today. I've been working at the same company for 26 years. And 26 years is a long time, but it's especially a long time in technology, IT, and on the internet. And we almost forget, well, actually there are people in the audience who weren't alive 26 years ago, so they haven't forgotten, they don't even know how different computing was 26 years ago. So when I joined F-Secure, I was a programmer. I came to work every day to program, which means every desk had computers. Just like we have computers today at our offices. We had PCs and Macs, just like today we have PCs and Macs. But the difference was that those PCs and Macs in 1991, they were not online. They were not on the internet. They were not even connected to each other. We did not have a local area network. We just had a bunch of computers which were not connected. So if you wanted to move files like documents, you had to use these. Remember these? Some of you don't even know what they are. This is a USB drive, thumb drive from 1991. 360 kilobytes of data. So during these years, during the last quarter of a century, we've seen a massive revolution. A revolution where every single computer on the planet has gone online. 25 years ago, they were not online. Today, they are all online. And now, we are about to see the next revolution. And the next revolution will be that everything else will go online. So far, we've seen computers go online. Now, we will see everything else going online. And this revolution is already underway. And it's happening, and it's going to happen during our lifetime. And then after that revolution, if we are lucky, we might live long enough to see the next revolution after that. And that, I believe, will be the revolution of general AI. And I do believe it's going to come. And I do believe it's going to be the single most important event in the history of the mankind. So we live exciting times. In fact, I consider us all to be very lucky to be alive during these defining years for the mankind. So, my job is to hunt hackers. I'm a hacker hunter. So I spend my time looking at the bad sides of the internet, the criminals, the scammers, the spammers, and so on. And you might think that because of my work, I would be a pessimist, but I'm not. I'm actually an optimist. I've seen the internet expose us to tons of new risks, but it's quite clear to me that the internet has brought us more good things than bad things. But bad things do exist, and we saw a very good example of that exactly 2 weeks ago. Because 2 weeks ago on Friday was the WannaCry Friday. WannaCry, which takes over your computer, changes the wallpaper on your infected system to this, drops a new program, and then runs it. And the program shows you a ransom note asking you to pay bitcoins to get your files back. And if we look at the spreading speed of WannaCry 2 weeks ago, take a look at this. This is how quickly it went all over the world, infecting hundreds of thousands of computers all over the world. Italy is somewhere there, right? So this was pretty bad. And this actually reminded us of what it used to be like 15 years ago, because we saw worm outbreaks like this regularly around 2003. You might remember big cases like Melissa and Love Letter and Slammer, Blaster, Sasser, all examples of worms which went around the world in a couple of hours. And this is exactly what WannaCry was. But what made WannaCry different was that it actually combined a self-spreading worm and a ransom Trojan. A ransom Trojan which locks your system, encrypts your files, and demands you to pay bitcoins to get your own files back. And WannaCry went and infected especially large companies. The reason why large companies were hit, or large organizations were hit more than others, was that it was targeting a feature of Windows called Samba, which is typically only enabled in very large networks. For example, very few home users have that feature enabled. And when you have a very large network of hundreds of thousands of workstations, it's hard to keep all machines up to date and patched at all times. And this is why we saw big problems in large companies or large enterprises, or, for example, in UK, with hospital systems. And the results of hospitals getting infected with ransom Trojans is pretty dramatic. I mean, when you have ambulance cars queuing outside of a hospital and they can't get patients into the hospital because there's a malware on the computers, that's pretty bad. And ransom Trojans are visible. Most normal malware we find doesn't show itself to the user. If your computer gets infected by a keylogger, which collects your passwords and your credit card numbers as you type them from your keyboard, you don't see anything. But with WannaCry and other ransom Trojans, you actually get a note on your screen. And we saw this note, this ransom note, all over the world. We all saw it, for example, here's a shop in Spain, and the door is taken over by ransom Trojan. Here's a fuel pump in China. Here's a mall information screen. This is from downtown Bangkok. That's an ad display. And here we have a French car factory stopped by a ransom Trojan. One more example. This is from a train station in Frankfurt. This is the timetable information that we can all see. And I know what you're thinking, that it's pretty bad that the timetable system is taken over by a ransom Trojan, but that's just a timetable. I mean, it's not critical. This is not the system which is actually controlling the trains. This is not the train control center. So, here's a train control center. What made WannaCry especially bad was that it was buggy. It wasn't programmed very well. So we don't know very many companies at all which would have paid the ransom and would have actually got the files back. Vast majority of the organizations which paid the ransom got nothing. And this is unusual. Most ransom Trojans actually deliver. Most ransom Trojans, once you pay the ransom, will give you your files back. They do this because they know that they need a good reputation. The ransom Trojan gangs need a good reputation. They need a reputation that if you pay, you will get your files back. Otherwise, nobody will pay. And WannaCry didn't deliver. We are right now tracking over 110 different ransom Trojan gangs operating on the internet, most of them from Russia. And these gangs are now angry as hell to WannaCry, because WannaCry spoiled their good reputation. It's much harder for them to do business from now on, because now people assume that paying the ransom doesn't work because it didn't work with WannaCry. Around 300 people or 300 companies paid the ransom, which is a failure. These guys caused a massive amount of damage, and even with the recent rise of Bitcoin value, it has doubled in value, they only made around 120,000 euros with the whole attack, which isn't a lot of money for the amount of damage they did. So, who were they? Who did WannaCry? Who wrote this Trojan? Who launched it? Well, we went looking for samples linked to WannaCry, and we found earlier versions, like, beta or alpha versions of WannaCry, already from February of this year. And hidden in the code of one of the early versions of WannaCry, we found a code snippet, an encryption routine, which we have seen before. This discovery was actually made by researchers at Google. Here on the left, early version of WannaCry. Here on the right, a piece of malware we found 2 years ago while investigating the attack against SWIFT. SWIFT, which is the international banking network used by international banks to move money around the world. Because 2 years ago, 4 different international banks were hacked, and the attacker tried stealing almost $1 billion. Billion with a B. They succeeded in stealing around $90 million. A lot of money. And we can link the SWIFT attack to an attack which happened 2 years earlier. An attack which happened in Hollywood. An attack against Sony Pictures. And Sony Pictures was hacked because they were about to release a movie. A movie in which the dictator of North Korea, Kim Jong-un, is killed. Sorry for spoiling the movie if you haven't seen it. Spoiler alert, Kim Jong-un gets killed in a chopper accident in the movie, The Interview. And as Sony Pictures was hacked before this movie was released, because of this movie, US intelligence agencies immediately responded by making a public notice saying that Sony Pictures was hacked by the government of North Korea. And this was incredible. Like, can you imagine a government getting angry about a movie? So angry that they hack a movie studio, overwrite their files, delete their servers, leak their internal emails, and publish the medical history of their employees. Later on, we learned how US intelligence knew this. They knew this because they had hacked the North Koreans, and they were watching them do it. That's how they knew. So, if we believe that Sony was hacked by North Korea, then we can link that to SWIFT. It's highly likely that it's the same attacker who did the SWIFT attack. And we can link SWIFT to WannaCry. So it's highly likely it's the same attackers. And this would mean that North Korea wrote WannaCry, which is incredible. It's hard to believe a government resorting to ransom Trojans, to steal money. Governments don't steal money. Oh, I guess governments steal money from their own citizens by taxing them. But in general, this is incredible. But we have to remember that North Korea is not a normal country. North Korea has been engaging in organized crime to make money before. North Korea has been printing fake money for a decade. They print fake dollars in the official government money printing presses. So maybe this was an attempt by the North Koreans to budget or to balance their budget deficit by using ransom Trojans. Nevertheless, it is an incredible case. Now, I told you that we found earlier versions of WannaCry. How did we find them? Well, we found them because we have a very large collection of malware. You might call it a big data collection. We have millions, actually, we have billions of samples in our collections, terabytes of malware collected over 30 years. And the only way we can keep up with the growth of malware is to use machine learning. We actually call it ourselves labs automation because the way we think about this is that we automate the work of human analysts. But we are now receiving hundreds of thousands of malware samples every single day, and the only way we can keep up with the work is to automate it. So we actually run systems which are collecting samples automatically, collecting them by getting infected by themselves. Then they analyze the samples by throwing them into virtual machines and executing them, and then we have a machine learning system looking at the results. Like, what did this program do when we ran it? And then the machine makes the decision. Is this good or is this bad? It is sort of an artificial intelligence system replacing the humans. And we've been doing our work like this for the last 7 years. So this isn't a new technology in the field of computer security, but it is getting more advanced and faster all the time. And it has to be getting faster because we are finding more samples every single day. So I told you that the next revolution will be when everything goes online. Not just computers, but everything else. This is the IoT revolution. And the way I think about it is that anything that we plug into the electricity grid, we will be plugging into the internet grid. Everything will be going online. Some of them will be going online because these new devices, online devices, will have new features for us consumers. However, some of them will be going online without giving any features to users. You can imagine an IoT toaster, and you don't really need internet in a toaster. There's no point in having an internet toaster except for the manufacturer, because the manufacturer wants to collect analytics. They want to collect information, and the way they get information about their customers, their toaster customers, is by putting in a chip, which puts the thing online. And now they know where their customers are. Now they know how often do they toast, what time of the day do they toast bread, what kind of bread do they toast, how often do they have failures, where exactly their customers are. Do they have more customers on the west side of Milan or on the east side of Milan? And if there's less customers on the west side, maybe they should advertise more on the west side. I mean, this is valuable information. And this means that any device, even if it makes no sense, things will be going online so they can collect information for the manufacturers. And this means there's no way for us to avoid this revolution. You cannot avoid the IoT revolution by refusing to buy IoT devices. Eventually, that's the only kind of devices that will be available, and you won't even know that they are online. In some cases, the things that are going online are things that we traditionally didn't even plug into the electricity grid. I'll give you an example of this. I'll show you an IoT mattress. Yes, you heard me right. A smart mattress, an IoT mattress, a thing that you sleep on. Because there actually is a company in Spain which is building IoT mattresses. And I know what you're thinking, like, why would you want to have your mattress on the internet? Well, they put sensors in the mattress, and then they have a mobile app. And when you are out of your home and your mattress is being used in a suspicious way, it will send a message to your phone. Seriously. I mean, you will get, visualization of how the bed is being used. And of course, this is being made in Spain, of all countries. And it looks like a joke, doesn't it? It's a real product. And it's a great example of how engineers were too busy thinking how they could do this, that they would stop and think if they should do this. I'm not sure this is a good idea at all. But it's a good example of how things are changing. And I've defined a law on smart devices. The law is that if something is smart, it's vulnerable. So, a smart phone, a vulnerable phone. A smart watch, vulnerable watch. Smart car, vulnerable car. This is the way it works. An example, here's a dishwasher. A smart dishwasher, a vulnerable dishwasher. We found a vulnerability from this dishwasher, a web server directory traversal vulnerability. So when you connect to the web server on this dishwasher, you can send this get command and steal the passwords from the device. Let me repeat the beginning of my last sentence. When you connect to the web server on your dishwasher, like what the hell? Web servers on dishwashers. This is the world where we live today. And when everything is online, then they need to be updated and patched and maintained, and the cloud backends have to be running for things to work. Here's somebody tweeting about how he's driving to work, and he notices that his car is updating its operating system as he's driving, which is a little bit, would make me a little bit nervous, but apparently it works. And we saw a good example last month what happens when cloud fails. Most of these devices have a cloud backend, and that cloud backend almost always is running in Microsoft Azure or Amazon AWS. And last month there was a failure of Amazon AWS storage platform. It went down for several hours. And during those hours I went to Twitter to search for reports from people who were reporting what fails, what doesn't work now that Amazon is down. That was mostly websites and mobile apps which didn't work. But then there was this guy who was reporting that his oven in his kitchen was on when Amazon went down, and now he can't turn his oven off. You can't turn your kitchen oven off because Amazon is down. What the hell? When we design our systems, we have to design them so that when things fail, they fail safely. And part of this problem is that the consumers and customers who use these devices don't configure them right. Which reminds me of these. Remember these? Video players, VHS tape players. We all used to have them. Okay, not maybe every one of us, but the older one of us used to have these. And you would go to your friend's house, and in the living room they would have a big TV and a VHS player. And the display of every VHS player at every house, everywhere on the planet, was always displaying the same thing. Every single one of them was always blinking 12, right? Am I right? I'm right. Why were they blinking 12? Because when you plug it in, it doesn't know what time it is. And now it expects you to read the manual to set the time. And we never did that. And this is the same problem we have today with our IoT devices. We go and buy IoT devices. We put them on the internet, and we never configure them. We never change the password. We never segment the network. We never build user accounts, so only some users could use the device and others could configure the device. And this is one of the reasons why we have all these problems. So we've been working on IoT security at F-Secure for almost 3 years now. And we last week actually published a product called Sense, which we believe will be the first step in securing these IoT devices. Because we can't secure the IoT world the same way we secured computers. You will not be able to run an antivirus on your toaster. I work for an antivirus company. I will promise we will not make F-Secure antivirus for toasters. That's not going to happen. the only way we can secure the future of internet is with dedicated devices like the one we've been building. And for that, we will need everybody's help. Thank you very much. Thank you.